Hello friends, good evening. Welcome to Maths IPE classes by NEET World. So today we will be discussing a topic from Maths-2A. That is, in the previous class we have already discussed the statistics topic, that is measures of dispersion. So today we will be continuing the topic from the statistics, another topic, that is probability, highly important topic, okay, where we will be getting lot of LAQs, that is very important LAQs which are very easily solvable because they are predictable and also very simple. Okay, so we will have a discussion on Maths-2A. Okay, in the previous class we had a discussion on Maths-2B. What is the topic that we dealt? We dealt with parabola. So tomorrow we will be having continuing with the discussion of probability if we can't finish today, and we will also be having the discussion of integration. Okay, that is pertaining to 2B. Integration, highly important and also very scoring and also high weightage topic that will be dealing tomorrow. Okay, so now let us start with our discussion on probability, friends. In probability, you have to understand there are certain theorems. Okay, they will ask directly the theorems and also sometimes they will ask theorem based questions. So this is the first question, friends, pertaining to probability. So we are doing the LAQs. I will not be defining too much about what is probability and all these things. This I will be doing when we do SAQs, VSAQs. Okay, let us see, but I will be talking about mainly about the LAQs. So first thing, the question that they have asked is state and prove the addition theorem on probability. So first thing you have to understand, certain times they will only give the statements, you have to understand that is the addition theorem, you have to prove. Okay, prove this they will say. Okay, certain times they will ask state and prove. See, they have asked the question multiple times, that is in many examination, many years they have asked the question, that is the state and that is the question from what is that addition theorem, that is the question from probability, friends. So let us start with the first question, that is what they are asking, state and prove the addition theorem. So let us start with the discussion, friends. So first of all, what is the addition theorem that says? Okay, question, state and prove the addition theorem. What is the addition theorem that is saying? Okay, so see here, if we talk about the addition theorem, okay, addition theorem, what does it say? Okay, so see here, let E1, E2 be any two events, be very simple statement when it comes to addition theorem, be any two events, and let P, capital P, be the probability function, Okay, then what does addition theorem says? Then probability of E1 union E2. What is it? E1 union E2. So this will be equal to probability of E1 plus probability of E2. Okay, this you would have learned from the sets. E1 union E2 is equal to E1 plus E2 minus E1 intersection E2. Same probability we have to add it. So that is probability of E1 union E2 is nothing but equal to probability of E1 plus probability of E2 minus probability of E1 intersection E2. Okay, this is the statement of addition theorem. Okay, this is the statement of addition theorem. Put it in box. You have to show that this is the statement of addition theorem. Now you have to prove this. Okay, we have to prove this addition theorem. Okay, we have to prove this addition theorem. So let us take this. Okay, so we have taken this, given, we have to prove this, given E1 and E2 are any two events, okay, and let S be the sample space, okay, let S be the sample space, okay, let S be the sample space. We will write it like this. Now let us go to the next page. What they are telling us, we have to prove. So let us take it case 1. There are two cases. So case 1, okay, what does it say? Okay, let E1 intersection E2, okay, be a null set, that is 5. That is intersection, E1 intersection E2 means what? E1 intersection E2 means what is common between E1 and E2? There is nothing common, we will take in the first case. So we have to draw the figure also, it will carry marks. So this is, see here, this is the sample space. So E1 E2. So see here, is there anything common between E1 and E2? There is nothing common. That is E1 intersection E2 is a null set. So this is what we will take. So what will happen to the addition theorem, therefore probability of E1 intersection E2 will become what? If it is a null set, it is 0. Therefore, probability of what is the addition theorem says? E1 union E2 is nothing but equal to probability of E1 plus probability of E2, okay, minus 0. Okay, this is what we will have, or you can write it just like this, because this is becoming equal to 0. This will become equal to 0. This is what we got. So case 1. Now case 2. What is this case 2? In case 2, what we will take? This is obvious, pretty obvious. You will understand. Let E1 intersection E2 is equal to 5. Now we will take that is a null set. We will take that it is not equal to 5. That is, it is not a null set. That is the second case. Okay, like these two cases you have to take and prove. So second case is what? Let E1 intersection E2 be not equal to the null set 5. Okay, be not equal to the null set 5. Then what will happen? That means there is something common, correct? There is something common. What is that common thing? Let us see. There is something common. This is E1, this is E2. Okay, so let us write something common here. So let this be common thing here. Okay, and also E2 has something. Okay, also E2 has something. Okay, this is something that E2 has. Okay, E2 has. Now see here, let me write for your reference, let me write it here. So see here, E1 intersection E2, okay, there is some common thing. Okay, and also E2 minus E1, that is only in E2, but it is not in E1. Okay, what is that we have? See here, what is that common thing? The common thing is represented by this red sign, okay, red color, and that thing, that is E2 minus E1, that is represented by this yellow lines. Okay, yellow lines, it is represented by this yellow lines. Okay, this is what we have. This you need not write, I have written for your reference, for you to understand what does it mean. Now see here, let us come back to the proof here. Then if it is not equal to this, then what will happen? Then E1 union E2. Okay, what will happen to E1 union E2? You have to think. Okay, what will happen to E1 union E2? You have to think. Okay, so see here, then E1 union E2 will be equal to, see here, E1 union E2 minus E1 it will become. Okay, what it will become? E1 union E2 minus E1 it will become. E1 union E2 will become E1 union E2 minus E1 it will become. E1 union E2 minus E1 it will become. And also see here, E2 intersection, okay, E2 minus E1, okay, E2 minus E1, okay, E2 intersection E2 minus E1. What will happen? E2 intersection E2 minus E1, okay, E2 intersection E2 minus E1, E2 intersection, that is not intersection, it should be E1. E1 intersection E2 minus E1, this will become equal to 5. Okay, this will become equal to what? Intersection E2, it will become equal to null set. So E1 and also E2 minus E1. E2 minus E1 is what? E2 minus E1 is this one. Okay, then E1 intersection this one, it will become equal to 5. That is, there is nothing common between this. E2 minus E1, E1 intersection E2 minus E1. Okay, E1 intersection E2 minus E1 will become equal to 5. Okay, this is what we will have. Okay, this is what we will have. Also, you have to understand what does this E2 minus E1 means. What does this E2 minus E1 means? This you have to, don't have to write it here. Okay, I will write here. Okay, E2 minus E1. Okay, E2 minus E1 is nothing but equal to E2 intersection E1 minus E2. E2 intersection E1 minus E2. Okay, this you have to remember. Okay, E2 minus E1 is nothing but equal to E2 intersection E1 minus E2. This is what we have. Now let us take the addition theorem. Let us take the addition theorem. So what does the addition theorem state? Let us take it here. Let us take it here. Probability of, what is that we have? Probability of E1 union E2 is nothing but equal to probability of E1. Okay, what is it? E1. What is this we have here? E1 union E2. What is that we have? It is nothing but E1 union E2 minus E1. Correct? E1 union E2 minus E1. This is what we have. Correct? E1 union E2 minus E1. Probability of E1 U2. This is probability of E1 union E2 minus E1. This is what we have. Now, what we will have? Probability of E1. Okay, plus probability of union means plus. So this will get what? Probability of E2 minus E1. Okay, probability of E2 minus E1. Now I told you E2 minus E1 is what? E2 minus E1 is, we have here E2 minus E1 is E2 intersection E1 minus E2. So let me write it here. So this will become what, friends? Probability of E1 union E2. Okay, probability of E1 union E2. So this will become equal to what? Probability of E1. Okay, probability of, what is this? E2 minus E1 is what? Probability of E2 minus E1 is E2 minus E1. What is the thing we wrote? E2 intersection E1 minus E2. Okay, E1 minus E2. Therefore, what I should write? Therefore, what I should write here? Therefore, E2 minus E1. What I wrote before, I am writing it here again. That's it. E2 intersection E1 minus E2. Okay, intersection E1 minus E2. So this is what, friends? This is nothing but equal to probability of E1 plus probability of E2, okay, minus probability of E1 intersection E2. That's it. Okay, minus probability of E1 intersection E2. This is what we have. Okay, intersection E2. So this is what I wrote. So what is this here? Same thing I copied here. Okay, P of E2 intersection probability of E1 intersection E2. That's it. Okay, E2 intersection E2. Okay, probability of E2 minus E1 intersection E2. That is what I write. So probability of E1 union E2. This is nothing but equal to probability of E1, probability of E2 minus E1 intersection E2. What is this? This is nothing but what is that we required? Probability of E1 union E2 is equal to probability of E1 plus probability of E2 minus probability of E1 intersection E2. We got this. We got it. So that is what the addition theorem we wanted. So hence we have proved, we have stated first and we have proved it also. Okay, we have stated first and we have proved it also. This is what the addition theorem states. Okay, clear? So these are the steps you have to follow. Neatly you have to take it. Okay, step by step you have to write each and every step. Even if you write more steps, no problem, but you should not reduce the steps. Okay, if you have to get full marks. Okay, each and every step you have to show to the examiner neatly. Clear? Got it? Okay. Let's move to the next question, friends. Next question. State and prove the Bayes theorem. Okay, next question is what I told you. Today's class will be more about the theorem only. Okay. Okay, in the next class we will be solving about other numerical based questions of probability. Now we will be talking about the Bayes theorem. State and prove the Bayes theorem. Okay, state and prove the Bayes theorem. So let us talk about the Bayes theorem first. So second question, they are talking about the Bayes theorem. Okay, Bayes is a scientist, mathematician. His theorem, or he gave a theorem on probability. What does it say? Okay, what does it say? So let E1, E2, E3 up to En be mutually exclusive. What does it say? E1, E2, E1 up to En be mutually exclusive, and I will tell you what is mutually exclusive and exhaustive. I will tell you. Be mutually exclusive and exhaustive events. And exhaustive events of a random experiment. Random experiment with sample space S, with sample space, that also you should write, with sample space S. Okay, with sample space S, such that probability of EI, okay, probability of EI, okay, is greater than 0, okay, where I is equal to 1, 2, 3 up to N. Okay, probability of EI is greater than 0. It is not equal to 0, greater than 0. Okay, greater than I is greater than 1, 2, 3 is up to N. I is up to N. This is what we have. Okay, and also for any event A, okay, P of A is greater than 0. This also you should consider. For any event A, probability of A is also greater than 0. Okay, now given that, okay, mutually exclusive and exhaustive events. Mutually exclusive means what? So if I write E1 intersection E2, okay, mutually exclusive means there is nothing common. Okay, so if instead of writing E1 intersection E2, let me write it as EI intersection EJ. Okay, is equal to a null set where, okay, I is not equal to J, where I is not equal to J. Okay, this is what mutually exclusive. Okay, mutually exclusive. So first we have to state known. Instead of stating, I am going for proof. So see here, for any event P of A greater than 0, what will happen? P of I have to state first. P of, what is this? P of E of K, P of EK divided by A is given by P of EK into P of probability of A by EK divided by summation probability of, what is this? Probability of E of I, okay, probability of E of I okay, probability of E of I running from 1 to n, okay, probability of E of I into probability of A by E of I, okay, probability of A by E of I. This is what the Bayes theorem states. This is what the Bayes theorem states, friends. Okay, this is what the Bayes theorem states, friends. Okay, okay, this is what the Bayes theorem states, and also you have to write where K stands for where K is equal to 1, 2, 3 up to n. Okay, 1, 2, 3 up to n. Okay, where K is equal to 1, 2, 3 up to n. This is what the Bayes theorem states, friends. Okay, this is what the Bayes theorem states. You have to remember. Okay, this is what the Bayes theorem states. You have to remember, friends. So this is what the Bayes theorem says. So this everything is what up till here what we wrote. This is the statement of the Bayes theorem. Okay, up till here what we wrote. This is the statement of the Bayes theorem. This is the statement of the Bayes theorem, friends. Okay, now we have to prove this. This what we wrote here. This statement we have to prove this. What is this? This statement what we wrote. We have to prove this statement. Okay, how to prove this? So let us take up the statement is given. Based on that only we will start with the proof. Okay, we have to start with the proof. So proof. Okay, proof. It is given what? Given what is it they are given? Given P of EI is greater than 0 where I is up to 1, 2, 3 up to n. Okay, up to n. So this is what they have given. So this is what they have given, and also up to n. This is what they have given, and also they have given E of I intersection j. Okay, E of I intersection Ej. Okay, since they have given E of I intersection j is nothing but equal to a null set. Null set means what? They are mutually exclusive. Okay, mutually exclusive events. Mutually exclusive. Okay, mutually exclusive. E of I intersection Ej is 5. Okay, then also union I running from 1 to n. Okay, I running from 1 to 1 n. E of I is equal to what? E of I is equal to what? Is equal to sample space. S is nothing but sample space. Okay, sample space. Now you will have a lot of confusion what I am writing. I will explain it. What is mutually exclusive event? What is sample space? I will explain. Okay, explain sample space. Why? Because it is exhaustive event. Okay, this is exhaustive event. This is because it is an exhaustive event. Exhaustive event. Okay, now let me take up a page. Okay, let me take up one more page. So let me explain what is mutually exclusive event. Mutually exclusive event. Okay, mutually exclusive event. So see here, let this be the sample space. Let this be E1. Okay, just like how I told you in addition theorem, E1 intersection E2. So E1 intersection E2, that is there anything common between E1 and E2? There is nothing common. There is nothing common between E1 and E2. Okay, so if I talk about E1 intersection E2, just a minute. Okay, if I talk about E1 intersection E2, if I talk about E1 intersection E2, so see here, if I talk about, so if I talk about E1 intersection E2, there is nothing common, so it is a null set. Friends. Now this is what mutually exclusive event means. Now let me talk about exhaustive event. So let this be the sample space again. Okay, let this be event 1, let this be event 2, let this be event 3, let this be event 4, let this be event 5, let this be event 6. Like this if we consider, okay, if we consider E1, E2, E3, E4, okay, up to E5, E6 if we consider, see here, if you add all these events, it is nothing but equal to what? It is nothing but what? Adding means it is nothing but even. See, that is union. E1, union E2, union E3, union E4, union E5, union E6 is coming out to be what? If you add everything, you are getting nothing but sample space. You are getting nothing but sample space. So this is nothing but exhaustive event. This is nothing but exhaustive event. I hope it is clear now. What is mutually exclusive? What is exhaustive event? Okay, what is mutually exclusive and exhaustive events? Okay, and exhaustive events. So see here, now this what we have taken. Now since, okay, we will take it here. Mutually exclusive. This is what it is. Since we have to take it here. Since A belongs to the sample space, okay, S sample space, sample space, okay, for any event A where P of A greater than 0, what will happen? This A will be equal to S, okay, this A will be equal to S, okay, this A will be equal to, I should write it as what, this A will be equal to, not S, this A will be equal to A, what is it? A will be equal to A intersection S, or what is it? I should write A intersection S or A union S, okay, what is that we have to write? A union S or A intersection S. So A will be equal to, okay, A will be equal to A intersection S, okay, A intersection S. But what is this S? So S is nothing but what? Okay, see here, from A, here what we will get? S is nothing but the union of this. So A intersection of what I will get? A intersection of S is nothing but union of, this is union of I running from 1 to N, I running from 1 to 1, E of I, this is what I will have, okay, I running from 1 to 1, this is what I will have, okay, this is what I will have, friends, this is what I will have, friends. So I running from 1 to N, this is what I will have, friends. Now what we should do? We should do the distribution theorem. We should apply the distribution theorem here, friends. That's it. We have to apply the distribution theorem here. Okay. We should apply distribution theorem here. That means what? You will come outside. So this will become what? U running from I to I running from 1 to N union. Okay. A intersection E of I. A intersection I of E of I. A intersection E of I. Now proceeding further, what I can write this? So if I apply probability of A, that is nothing but I'll get it as probability of, see, if I write probability of A, that is nothing but I can write this as, let me write it here. Okay. So this implies union of I running from 1 to N, okay, A intersection EI is nothing but, will give us nothing but equal to A intersection E1, okay, then intersection A intersection, let me write it as EI, A intersection EJ, like this we will get it, where I is not equal to J, okay, where I is not equal to J, this is what we will have, okay, this is what we will have, okay. So what I can do here, A intersection, okay, E intersection EJ I can write it, correct now, by distribution theorem. So E intersection J here is nothing but phi, so this will become equal to what? A intersection phi, this is what I will have, A intersection phi, this is what I will have, friends. A intersection phi, A intersection null set is null set only, so we will have phi only, we will have what? Phi itself, Now if I apply probability of A, let us go to the next page. If I apply probability of A is nothing but equal to summation of I running from 1 to N, okay, probability of what is this? Probability of E of I divided by A, okay, probability of E of I divided by A, this is what I have, probability of A intersection EI, okay, probability of A intersection EI, okay, I running from 1 to N, this is what I will have, okay, I should write what? Actually I should write A intersection EI, this is what I have now, I should write here, probability of A intersection EI, this is what I should write, summation of this only I should write, okay, probability of A intersection EI I should write, probability of A intersection EI I should write, okay, this is what I have. Now this will be equal to what? I can write this as probability of EI into probability of A by EI, okay. How I can write this? Please think of it, how I can write this? I can write this because of, by using multiplication theorem, okay, using multiplication theorem, I can write the summation of I running from 1 to N here also, here also, clear, using multiplication theorem I can write this, okay, summation of I running from 1 to N, okay. Now let me take the thing that we have to prove, probability of E of K divided by A, okay, this I can write it as what, friends? This I can write it as probability of E of K intersection A divided by what I can write? Probability of A. How I can write this? Using conditional probability theorem. You have to write this reason here, okay, using conditional probability theorem, you can write this, okay, using conditional probability theorem you will get this. Now again I will apply what? Again I will apply same thing like this, I will apply multiplication theorem, okay, and applying multiplication theorem what I will get? This, for this I will get it as probability of E of K into probability of A by E of K divided by what I will get? Probability of A is what? Probability of A, this is what I got. Probability of A is, this is what I got. See here, same thing. Summation of I running from 1 to n, okay, probability of E of I, okay, probability of E of I, okay, into probability of, what is this? Probability of A by E of I running from 1 to n, where k is nothing but equal to 1 to the up to n. Okay, this is what I have. This is what I have. Okay, finally this is what I have. Okay, we don't have to write this also. This further, this is enough. So this is nothing but equal to what? This is nothing but equal to probability of E of k, probability of E of k divided by A. This is what I have. This is nothing but equal to what? This is nothing but equal to the proof of the Bayes theorem. You got the Bayes theorem. That itself is the proof. Clear, friends? This is how you got to solve this question. Probability of E of k by A. This is what we have. The proof of the Bayes theorem. Clear? This is how you got to solve this question. So you have to take mutually exclusive events and exhaustive events. I told you what is mutually exclusive and exhaustive events. This is what the Bayes theorem says. First of all, let me explain the Bayes theorem in simple words. So see here. So this is the thing. What did I say? This is the thing. So let us take that there are two bags. 1, 2. Okay. First bag is having 2 white balls and 3 black balls. Okay. Second bag is having 3 white balls and what is it? It is having 4 black balls. Now the probability of getting a white ball from second bag. Okay. So if I talk about second bag, probability of getting a white ball will be 3 by 4, okay, or 3 by 7, it should be 3 by total, 3 by 7. Okay. Probability of getting white ball from second bag. Okay, this is 3 by 7. If I talk in ulta, that is if I talk it in reverse terms, that is what I will do, I will blindfold you people. I will ask you to take the ball, okay, you will take from any of the bag, you don't know that, okay, I will say that you have got the white ball. I will ask the probability that you got the white ball from the first bag. Okay, now what I am asking? I am asking that you got probability of white ball. So probability that you got the white ball from the first bag is what? Probability that you got the white ball. Earlier, probability of getting the white ball. Now I am telling probability that you got the white ball, that is perfect. But what is the probability that you got it from the first bag? So that is nothing but to find out that we will use the Bayes theorem. Probability of first ball, probability of getting the first ball from the, probability of getting the white ball from the first bag is nothing but equal to probability of I, okay, into probability of, what is it? W by I, okay, divided by summation of probability of I, okay, summation of probability of I running from 1 to n. This is what we will have. Okay, this is what we will have. I running from 1 to n, probability of W by I. Okay, probability of W by I. This is what we will have. Okay, this is nothing but the Bayes theorem. This is the explanation of the Bayes theorem, friends. Now let us take up a question on Bayes theorem that is given. Okay, let us take up a question that is on the Bayes theorem that is given, that is asked in the previous years. Okay, that has been asked in the previous years, and let us solve the question. One of the question from the previous years, that is based on the Bayes theorem, that will give you crystal clear clarity about the Bayes theorem and its usage. Okay, so let us take up the question. Okay, this is the previous year question they have asked. Okay, what is the question they are telling? They are telling, okay, 3 urns have the following composition. 3 urns of the following composition. Okay, following composition: urn 1, urn 2, okay, urn 3. They are telling 1 white, 2 black, 2 black. They are telling second one 2 white, 1 black. Next they are telling 2 white, 2 black. Okay. They are telling one of the urn is selected at random. One of the urn is selected at random. One of the urn is selected at random. Okay. They are telling and a white ball is drawn. And a white ball is drawn. This is what they are telling. White ball is drawn. The question is, okay, find the probability that it is drawn from drawn from urn 3, that is drawn from urn 3. Okay, same thing. So see here, this is the question. Just a minute. Excuse me. Have a look at the question. So 3 urns, they will take a ball. It turns out to be a white ball. Okay, they are telling that what is the probability that you are getting the white ball? Fine. What is the probability that you are getting it from third urn? That is urn 3. Now let us do this solution. Okay, step by step let us write down. Okay, what is the given solution? It is given that urn 1, urn 2, urn 3. Okay, urn 3. Okay, it is containing what? 1 white, 2 black. It is containing 2 white, 1 black. It is containing 2 white, 2 black. Okay, now we have to write down, we have to divide. I should write it below. Okay, let me write it here only. Let E1, E2, E3 denote selecting a ball or white ball, selecting white ball from selecting a ball, or I can take it as, instead of selecting white ball, I should take it as selecting a ball from, or picking a ball, selecting a ball from urn 1. This is event. Okay, selecting a ball from urn 2. This is selecting a ball from urn 3. Okay, this is selecting a ball from urn 3. Okay, this is the thing. Okay, now what they are asking us is, we are getting white ball, but what is the probability that they are getting it from urn 3, that is event 3. Okay, we have to find out. Now see here, you have got E1, E2, E3. Okay, now probability of E1. Probability of E1 is what? Getting it from urn 1. Out of all the 3, you have to get from urn 1 means, that is out of 3, 1. That is probability of E1 is 1 by 3. Okay, probability of E2 is what? It is also 1 by 3. Probability of E3 is what? Probability of E3 is what? Probability of E3 is, this is also 1 by 3. This is also 1 by 3. Correct? This is also 1 by 3. Now W, let W represent getting a white ball. Okay, now we have to find out probability of getting a white ball from E1. Okay, probability of getting a white ball from E2. Okay, probability of getting a white ball from E3. Okay, clear? Now see here, getting a white ball from E1. Okay, getting a white ball from E1, that is E1 means urn 1. 1 out of 3. So this is 1 by 3. This is what? 2 out of 3, that is 2 plus 1, 3. This is 2 by 3. This is what? 2 out of 4. 2 by 4 means I can write it as 1 by 2. This is what I have. Okay, probability of getting this one. Now they are asking us what? They are asking us to find out that what is the probability that you got the white ball. Correct, fine. Okay, but you are getting it from urn 3. Urn 3 means event 3. Okay, this is what they are asking us. So for this, by Bayes theorem, what I can write? This I can write it as what? Probability of E3 into what is it? Probability of E3 into probability of W by E3 divided by, okay, summation of I running from 1 to 3. There are 3 urns. I running from 1 to 3. Probability of E3 into probability of what I should write? EI into probability of W by EI. Okay, summation of this. So this is equal to what, friends? I can write it here, probability of E3 into probability of W by E3. So this is summation, correct? This is summation. So I can write it as what? Probability of E1 into probability of W by E1, probability of E2, probability of W by E2. Next, probability of probability of E3 into probability of W by E3. So third, okay, this is what we have to fill the values. Just by filling the values now, you will get it. Okay, this is by what? You have to write the reason here. So therefore, using Bayes theorem, you have to write the reason. Okay, you are using what? Using Bayes theorem, you have to write the reason. So this is the application of Bayes theorem. This question is based on the application of Bayes theorem. Now probability of E3. So let me write the values here. Okay, let me write down the values here. So what we'll get here? So here we'll get the answers. Probability of E3 is what? Probability of E3 is 1 by 3. Okay, 1 by 3 into W by E3. W by E3 is what? W by E3 is what? 1 by 2. Okay, 1 by 2. Just put the values. So this is what? Probability of E1. Probability of E1, E2, E3. They are all what? 1 by 3 only. I'll write 1 by 3 plus 1 by 3 plus 1 by 3. That is E1, E2, E3. 1 by 3 only. W by E1 is what? W by E1 is 1 by 3. W by E2 is what? 2 by 3. Is 2 by 3. W by E3 is what? W by E3 is what? 1 by 2. This is 1 by 2. Okay, 1 by 2. Now let us solve this. Okay, now let us calculate this. We will get it as what? 1 by 6 divided by what is this? What is this we have? 1 by 9 plus 2 by 9 plus what is this? 1 by 6. So 6 and 9, what is the LCM, friends? 6 and 9, the LCM is what? 6 and 9, the LCM is 18. So this will become what? 1 by 6 divided by 1 by 18. This will be what I can write? This, let me write it. See, I can further simplify here only. Let me write it here. 9 2s are 18. Here also 9 2s are 18, 2 2s are 4. Okay, 6 3s are 18 plus 3. So this will be what? 1 by 6 divided by 3 plus 4, 7, 7 plus 2, 9. Okay, 9 by 18. So this will be equal to what? 1 by 6 into 18 by 9. Okay, 1 by 6 into 18 by 9. This will be what? 6 1s are 6 3s are 3 1s are 3 3s are. So what is the answer we will get, friends? Probability of getting the white ball from where? From on 3 will be equal to 1 by 3. Okay, by applying the Bayes theorem we got the solution to this question. Okay, by applying the Bayes theorem we got the solution to this question, friends. Clear? This is how you got to solve this question. This is how you got to solve this question. Clear, friends? Okay, so see here, this is the question. So R 1 2 3 are there. Okay, they are having white and black balls. So they are telling on randomly picking we are getting the white ball, but what is the probability that they are getting it from the arm 3? That is nothing but we have to use what? Bayes theorem. By Bayes theorem, by applying Bayes theorem we have to get this. We will get it as 1 by 3. But before that, each and every step will carry marks. Okay, you have to define the event. Okay, then you have to find out W means getting a white ball from on 1, on 2, on 3, this probability. Then we have to use this 1. This is 1 is what? By using the Bayes theorem. This is the Bayes theorem we are applying here. Okay, this is the Bayes theorem we are applying it here. This you have to write it here by using Bayes theorem. To the examination, to examiner or the evaluator, you have to show that the Bayes theorem you are applying here. That words you have to write it. Okay, clear? This is how you can solve this question, friends. This is how you can solve this question. Okay, let us move to the next question. Okay, this is similar to that. Okay, this is similar to that. So see here, look at this question. Question number 4. Suppose that an urn B1 contains 2 white and 3 black balls. So let me maximize this. This is similar to that. See here, let me write it. Suppose that urn 1 contains, let me write down, urn B1 contains what? 2 white and 3 black balls. Okay, B2 contains what? B2 contains another one. B2 contains 3 white and 4 black balls. Okay, on one urn is selected at random and a ball drawn from it. If the ball drawn is found to be black, okay, ball drawn is found to be black, let us find the probability the urn was chosen was from B1. So here we have to find what? The probability of getting black, okay, from B1. Okay, so let us define this again. Okay, let E1, E2. So this is what? Selecting a ball from B1. Okay, on B1. This is selecting a ball from on B2. W is getting, what is it? Getting, not W, let us write it as B. B is getting a black ball. Getting a probability of getting this is getting a black ball. This event is getting a black ball. They are telling black ball, correct? No, they found black. Okay, getting a black ball. Now probability of E1. Okay, probability of getting it from E1 means getting it from B1. That is 1 out of 2. That is 1 by 2. Similarly, probability of E2. That is also 1 by 2. This is what we have. Now, what we have to write? Probability of getting a black ball. Probability of getting a black ball from B1. That is from on 1. That is event 1. Okay, probability of getting a black ball from here. Black ball is how much? 3. So total is how much? 3 plus 2, 5. So this is 3 by 5. Okay, then probability of getting black ball from E2. Okay, this is how many black balls are there here? 4 black balls. This is 4 by 7. 4 by 7. This is what we have. This is what we have, friends. Now we have to find out probability of getting the black ball. Okay, probability of getting the black ball. We got the black ball. That what is the probability that we got it from? B1. B1 means that is E1. B1 means that is E1. Okay, that is E1. Okay, let me do it here. Probability of getting the black ball from E1. Okay, so this will be equal to what, friends? This will be equal to probability of E1, okay, into probability of what is this? Probability of B by E1 divided by what is this? Probability of E1 into probability of B by E1 plus probability of E2 into probability of B by E2. This is what is the theorem we are using? Again, we are using Bayes theorem. You have to write this. Using Bayes theorem, you have to write this. You have to write the reason. Now let us put the value. Just put the values. Probability of E1 is what? 1 by 2. Probability of B by E1 is what? B by E1 is 3 by 5. Okay. Same thing you copy here, 1 by 2 into 3 by 5. Okay. Probability of E2 is what? 1 by 2. Okay. Probability of B by E2 is what? 4 by 7. 4 by 7. Correct? 4 by 7 we have. Okay. 4 by 7 we have. Now see here. I can take 1 by 2 common here. Here also 1 by 2 is there. So 1 by 2 into 3 by 5 divided by 1 by 2 into what is this? 3 by 5 plus 4 by 7. So I can do 1 by 2, 1 by 2 I can cancel. I will be left with 3 by 5 by 3 by 5 plus 4 by 7. So what I'll have? So see here, I'll have 3 by 5 by 3 by 5 plus 4 by 7. So 7 and 5, what is the LCM? That is 35. Correct? No? LCM is 35. So this will be 5 7 is 7 3 is 21. Okay, 21. 7 5 is 4, 5 4 is 20. This will be 3 by 5. Now on solving this 3 by 5, okay, into what is this? 35 will come up, divided by 21 plus 20 is what? 41. 41. So this is 5 1s are, this is 5 7s are, 3 7s are 21. 21 by 41. Okay, we will get what? 21 by 41. Correct? No? Let us see the solution here. Okay, yes, we got 21 by 41 here. So observe here, we got 21 by 41. Same thing we got it here. Okay, so we got the same thing here, 21 by 41. That is the right answer, friend. Therefore you have to write what? Probability of getting the black ball from urn 1, that is B1. B1 means urn 1, event 1. It is 21 by 41. This is the answer to this question. This is the way to solve this question. This is the final answer. You have to put it in the box. Clear? This is how you have to solve this question, friends. Clear? So Bayes, first we studied additional theorem. Okay, then we studied about what? Bayes theorem in detail. I told you what is mutually exclusive and mutually exhaustive events, all these things. Then we studied about what? Then we studied about the Bayes theorem, how to state and prove. Then application of Bayes theorem, we did 2 questions on this. Clear, friends? I will wind up now. In the next classes, we will study some questions on, do some question on multiplication theorem, conditional probability, all these things. Okay. So tomorrow we will meet again, we will be doing probability and also we will start with integration. Thank you, friends. Take care.